Hello and welcome. In this video, we are going to learn how to create a microbit balancing dot. As you can see in that video in the bottom right, you tilt the microbit and the dot kind of follows. And then we're going to gamify this a little bit with some modification to have a game where we kind of hunt a blinky dot that appears in a random position. And we collect as many as we can in 20 seconds and then get the score printed. So maybe I'm just going to finish this for the fun of it. And then we're going to build it. So now I'm going to have a score, and we're going to find out how many I managed to capture. And it was 13. Okay, so how do we go about this? We're going to do it in 2 stages, just the 2 stages that I demonstrated right there. First, we're going to build a balancing dot, and then we are going to actually gamify it a little bit. So let's begin. Search for microbit Python, open up that editor, and I'm going to zoom it in for you guys just a little bit. Or maybe not zoom in that way, zoom in this way. So yeah, I'm sure that code is pretty visible. So where to begin? Well, the balancing dot is going to have an X location, a Y location, it's going to have an offset. But for the beginning, we're really only going to specify the offset because the middle pixel is 2, 2. So that's where we're going to go. So we're going to say X offset equals to 2. And we're going to set the Y offset to the same value. So X offset is 2, Y offset is 2. Now comes the tricky bit. We got to set the X value and the Y value. Now the maximum value of the accelerometer is minus 1000 due to gravity. So this is something that we've got to factor in. So if you think about what's going to transfer 2000 to this way or to that way, you got to come up with a number. So, I mean, I guess it could be 1000, but in that case, you'd have to tilt it 90 degrees. So we're going to trial and error this a little bit. So the idea is you get the value of accelerometer dot get underscore x. So you get a value for x. And that's a value between negative 1000 and 1000. Then you got to divide that. And I'll just try to divide it by 500. So that's going to be as big as 4. And then you're going to add it to the offset, plus x underscore offset. Oops, that's not a function. X offset is just a variable. And then we need to get an integer value for that. Okay. Now, obviously, let's just test it for x and figure out what a good number is. And perhaps just find a way to print it. So let's just say display dot set underscore pixel, and you're gonna set the value of x. Then you're gonna say 2 for y. Strength is going to be 9. You can wait a certain amount of time. Sleep, say 200 there, and display dot clear. So this should actually have our dot doing something. So let's plug in a microbit. I've got a collection of them in front of me. Actually, I got 5. So I'm going to plug in this one. And good. It's there. It's been recognized. And let's download the code. So save it. I'll move these guys out of the way. And hopefully, if everything works, we should be able to tilt and move the dots. And then we can check the values. Okay, we've got some line error, and it's line 9. That's good. It's pretty high. Display dot set pixel. Yeah, name display. Display. All right, let's do this again. Save. Now we should be able to see that dot being able to, yeah, Now, think about how much I have to tilt it. So 500 is definitely too much. We want to make it less tilting than that. So 500 is all right, but let's make it half that. So if we make this 250, and then we can also produce the y. So y is going to be the int of accelerometer get y. We're going to have x and y. And now we can download, save. We should have a working moving dot. So let's try this out. So this is the middle, and you tilt a little bit. However, let's tilt too much, and it's going to go out of bounds. So the only thing we need to add to this is something that keeps basically the value of x between 0 and 4 and keeps the value of y between 0 and 4. So you could basically say if x is greater than 4, you can set x equals to 4. And you will do similar for upper and lower bounds. So if x is less than 0, you will set x to 0. And then you'll do the same for y. And with those, basically our dot is going to be completed. So this is going to be, these are going to be the y's greater than 4. When I download this, I should be able to move the dot around without crashing the microbit. So that keeps the indexes working, and if this all works, yay! So I can tilt all the way and everything stays as it should. That's brilliant. Okay, so now, stay flat. Well, with the cable plugged in, it always tilts it, as much as I'd like to keep the dot in the center. So let's have a look at what we can do to create that randomly generating dot. So maybe I get rid of this particular line, and maybe I full screen it so that we have a little bit more space for the code. Hopefully we can fit it all in. So we're obviously going to need to call the x and the y off the dot that's going to blink something. It reminds me a little bit of the snake game, so I'll just call it x fruit and y fruit. And I haven't defined them yet because I think from the very beginning I can make them random. So from random import star, and I think maybe I can just import rand int. Try it that way. I am playing with microcontrollers here, and the less memory you use, the better. So we can say rand int. What is it? So 0 to 4, 0, 4. So that's going to be the x coordinate. That's also going to be the y coordinate. We are also going to have a score that we're going to set to 0. And we can also play for a certain amount of time. And for that, we're going to use running time. So let's say basically finish time equals to running. So running time is the time now. Running time plus 20,000. So that means we're going to finish in 20 seconds. And instead of while true, you could just say while running time is less than finish time. So this is going to make the game last exactly 20 seconds. For the purposes of testing, I'm going to make that maybe even just 5, because it's just easier to test. I could probably collect one dot in 5 seconds. So now we need to generate this dot. Where we're going to put it, how are we going to put it? Now, since I want that dot to blink, I need it to be recognizable. I don't want it confused with my pixel. So we're going to set it, but we're going to make it blink, and I'll show you how. So we're going to have x fruit and y fruit. Those are going to be its coordinates. X fruit, y fruit. We're going to set it to the strength 9, but then I'm going to sleep 100. And then I'm going to set it to a different strength and sleep 100 again. So I'll still have that 200 delay, But in that 200, this will have blinked. I don't know what I'm going to put its strength, maybe 5. It should be noticeable that it's blinking between 9 and 5, but we can always change it. So now we've got this thing that's blinking. And I guess the thing that would remove it would be just to check if the x and the y of the fruit match up with the x and the y of basically our balancing dot. And if that happens, we just regenerate the x and the y of the fruit again. So that should be a simple if statement. If x equals to x double equals to x underscore fruit and y double equals to y underscore fruit. So those are the two variables. If they are identical, we regenerate the random dot. Now at this point, we are ready to test. If this works, we only need to add the score and we're going to be done. So let's give this thing a go. We'll download. It's coming. Exciting moments. I just need to see how good the blink is going to be. Oh yeah, that's pretty clear. Eat it. Yes. So we do eat it and it does regenerate. And it's over in 5 seconds, but that's fine. We figured that 20 seconds is going to be about the right amount of time. So every time we eat it, we can actually say score plus equals to 1. So we add 1 to the score. And when it's all over, we can display dot scroll score plus string of score. Since I have enough space, maybe I'll just show the score twice. Copy, paste. Yeah, that should do it. I'm pretty surprised that this whole game fit into 30 lines. Let's run it. Let's see if it works. 20 seconds. Fun times coming up. So the first time I got 13. Let's see if I can beat 13. No, this is not looking great. Here we go. No, I don't think I'm going to beat 13, but that's better. Oh, I'm just on a roll now. Maybe I will beat 13. Here we go. Score what? 14. I beat my previous record by 1. So that's the game. Program it in. See if you can beat my score. By all means, if you have other suggestions on what you can do to make this game better, put them in the comments. I would love to see them. Also, now that we got to the end of this, let me recommend some other videos you should check out. Here, I'm going to put a video that measures human reaction time, and that's also gamified. And over there, I'm going to put a video that's called a button masher, which we upgrade to also making quick decisions. So it almost merges with reaction time. Below will be a list linked that has a playlist of all my microbit Python videos. That's all for now. Bye-bye.